Welcome you all for the video lecture on fluid mechanics and machinery. In this video, we are going to see about course overview and introduction. Myself K. Davaslingam, Assistant Professor, Mechanical Engineering. Course overview. In this course overview, we have 5 modules. Module 1 is fluid properties. Module 2, flow through pipes and characteristics. Module 3, dimensional analysis. Module 4, pumps. And Module 5, turbines. Basically, first 3 modules are fluid properties and mechanics. Module 4 and 5 is fluid machinery. These are the course objectives.
All the phases of elements, solid, liquid and gas. By sound, we are going to understand what is solid, what is liquid and what is gas. Can you hear the sound? If not, hear once again. It clearly says the metal is fell down on floor. Hear the sound. This clearly says water flows in metal. Next, hear the sound. Yes, this is wind flow. This denotes gases. Next, we are going to see about element phases. Solid, liquid, gas. These are the element phases. Solid. The molecules in a solid are arranged in a pattern that is repeated throughout. Liquid. In liquids, molecules can rotate and translate freely. Gas. In the gas phase, the molecules are far apart from each other. In general, intermolecular bonds are strongest in solids and weakest in gases. Look at the figure A, B, C. A is represent solid, B is represent liquid, C is represent gases. Solid is bonded tightly, whereas liquid and gases flow freely. That's why it is called as fluids. Molecules are relatively fixed position in solid. The group of molecules move about each other in the liquid phase. Individual molecules move about at random in gas phase. This figure clearly shows how the particle or atom is arranged and it can move. In solid, it can vibrate but not move. In liquid, it can move, and gas also is able to move. Before going to understand the shape of the phases, we are going to understand the free surface. What is free surface? It is formed in liquid, so it does not form in gases. Then how? In liquid form, in gas it does not exist. Look at the figure. The gas can flow out, so there is no free surface. Now we can see the shape of the phases. Take the solid. Solid can take its own shape when we kept in another container. So solid has folds, shape and fixed volume. Whereas in liquid, it takes the shape of the container, so it forms the free surface and also it has fixed volume. Look at the bottom figure. It shows it will form the shape of the glass. And the next analysis figure shows that how the liquid molecule hit the wall of the surface. Next one is gas. It can move freely in the container and take the volume of the container. Next we are going to see about phases and its temperature comparison. Look at the figure. It shows a phase transformation by increasing the temperature. In x-axis, it is heat order. In y-axis, temperature. In minus 40 degrees Celsius, it is like ice, like a solid. Up to 0 degrees Celsius, it will be in solid mode. When we increase the temperature from 0 degrees Celsius to 100 degrees Celsius, it forms liquid. Look at the phase transformation in liquid portion, that means in this region. At 100 degrees Celsius, the liquid transforms to gas. This is a transformation phase. From 100 degrees Celsius, it will transform to gaseous state. This will be another comparison of phase temperature. When we increase the temperature, the ice cube forms a liquid. Again, we increase the temperature, it will be in a gaseous state. We can observe that In periodical table, how the elements are changes by increasing their temperature. The red one is gas, the green one is liquid, and the blue color is solids. So temperature is an important property for phase changes. This is a general introduction about the density. Look at the figure A, B, C. It's a solid, liquid, gas. The solid is tightly packed as we seen earlier. Liquid and gas are and not tightly packed. Density is mass per unit volume. Consider the each square in each object is unit volume. That particular solid is tightly packed, so it has high density. Liquid has even lesser density when compared to solid. Gas even lesser density when compared to liquid. This is a general introduction about compressibility. Gas is easily compressible when compared to liquid. The liquid is less compressible and solid is even less compressible. This is the overall comparison of phases: solid, liquid, and gas. This is a microscopic view of solid, liquid, and gas. In this video lectures, we are going to see about incompressible fluids, that is liquid. We are moving to the second part, application and existence of fluids. The first existence is human body and earth. Our human body and earth is worked by fluids. We consume water in our body. 78% of weight is water, and we inhale and exhale the air. As well as earth is also dependent on fluid transformation. Next one is drinking water. Without the water, we are not able to survive. Technically, we say the water is neutral fluid, standard liquid. The next one is butter. For butter, we need a small force is required to flow as a fluid. We call it as dilating fluid. Butter is the example of dilating fluid. Next one is milk and blood. It is the example of pseudoplastic fluid. The next one is we are using day-to-day life toothpaste. This is a technical name of Bingham plastic fluid. It requires initial force to flow. Next one also we are using day-to-day life cooking oil and honey. Technically we say it as exotropic fluid. This is also known as spinning fluid. Next one is rheofat fluid. Example is cream. It is also called as thickening fluid. This is the comparison between Newtonian and non-Newtonian fluid. The only Newtonian fluid is water. The other fluids are known as non-Newtonian fluid. Look at the top curve. It denotes fluid requires initial shear force. With this shear force being flow. Another important liquid is mercury. It has high density, greater cohesive force, and low vapor pressure fluid. The application of the fluid is used in pressure measurement devices. Example, manometer. This is we are dealing module 1, that is fluid properties. Next application is hydraulic lift. This we are seen in service stations with the application of Pascal law. Next one is hydraulic brake. This is applied in automobile applications. This is also we are dealing module 1. The next one is buoyancy and flotation. By these principles, the ship is floating. We will see in module 1. Next one is flow measurements. Potentiometer is measuring the velocity of fluid. This will be seen in module 2. Next example is dam construction. This we will see in module 3. Up to this first part, that means fluid mechanics. The upcoming things are fluid machineries. Pump is one of the machinery to transfer the fluid from one place to another place. It will be seen in module 4. Next one is turbine. It is a rotating element rotated by fluid as a driving force to generate the electricity. It will be seen in module 5. These are the various applications: gas cylinder, air filling instrument, petrol bunk, pump, refrigerator, air conditioning, aerospace systems, heat engine, cryogenic engine, and power plants. Up to this, we are seeing the overview of fluid mechanics and application of fluids. It will be helpful to understand interrelated courses like engineering thermodynamics, heat and mass transfer, hydraulics and pneumatics. Our next lecture is Module 1 Fluid Properties.